All right, we're talking about matter today, properties and changes. Chapter 8, Section 1. You should have your fill notes ready to go. Here we go. All right, so what is matter? Matter is simply anything that has mass and takes up space. I'm matter. Your desk is matter. Anything, your cat, a hammer, scissors, glue sticks, anything that has mass and takes up space is matter. So basically, it's everything that's around us in the world. Whether it's a solid, a liquid, or even a gas is matter because it does have mass and it does take up space. When we talk about chemistry, we'll get into chemistry a little bit in this chapter, not a lot, but chemistry is simply the study of matter and the changes it undergoes. Because when we do chemistry, we're actually changing it into something different, typically. So that's chemistry, the study of matter and the changes that it will undergo. Well, let's first talk about properties. There's two main types of properties you guys need to know. Number one, physical properties. Number two, chemical properties, which we'll talk about in a couple more slides. But what are physical properties? First of all, a physical property is something that can be observed without changing the identity of the substance. Some common physical properties that we need to know in class be state of matter, whether it's going from a solid to a liquid to a gas. Ice melting. It's still water. We're just changing it from the solid form to the liquid form. That's a physical property. Viscosity, how fast or slow a liquid's going to flow. Whether or not an item is conductivity, whether it can conduct electricity. Malleability, ductility, hardness. Magnetism is a physical property. Volume, mass, the length of an object, changing how short or long it is a physical property. It's still the same substance, it's just either shorter or longer. The melting and boiling points of objects, whether it's soluble, solubility, its texture. I can take a piece of wood and I can sand it. It's still a piece of wood, it's just smoother now. The density of an object, and finally, color. These are all physical properties. Let's get into a few of them I want to spend a little more time on. Solubility. Solubility is being able to dissolve a substance within another substance. For example, salt in water or sugar in lemonade. It's still physical property. Can we get that substance back? Yeah, we can. If we let the water evaporate, we'll see that salt form again once the water's gone. What about conductivity? Conductivity is a material's ability to allow heat to flow. Some metals are really good conductors of heat, better than others. Wood, though, is a poor conductor of heat. And that's what we're talking about when we're talking about conductivity. You don't see wooden pots for the stove. You see metal pots for the stove, so we can heat things up quicker. Some more physical properties I want to spend some time on. Malleability. That's how you say that word, malleability. It is the ability of a substance to be hammered into thin sheets. For example, I mean, you guys are used to aluminum. You've seen aluminum foil before, something like this. This started off as a big block, something like this. But now we've been able to pound it down into a thin sheet, much like this. I can take this, a physical change, and I crumpled it into a ball. It's still aluminum, I just changed its shape, physical property. I could take this, and I could take this hammer now, and I'm going to pound it. Malleability says I can hammer it into a thin sheet. Did I do that? Sure. So that is a physical property. Smaller, thinner, it's still aluminum foil. Now, what's ductility? Ductility is the ability to be pulled into wire. Some metals we can stretch out really far into wire. Copper wires you can see there. Here's one. I got this from the power company. This is an old power line. You can see this. I don't know how close I can get, but there you go. But you can see all those wires. That metal's been pulled into those thin strips. This is what's inside that power line that you see outside of your house. All right, so this was our ductility. And that's what happens, chemical change on the opposite side we haven't talked about yet. But you can see what happens once we get water involved and oxygen. We really start to change those wires into a brand new substance. All right, so that's ductility, the ability to be pulled into thin wire. Density of a substance is a ratio of its mass compared to its volume, and we'll talk more about that a little bit later in this chapter. But density for us, is the ability for something to sink or float in water too. We have this piece of pine. It floats in water. All right, so its density is less than 1 gram per centimeter cubed. Here I have a chunk of copper, and I'm going to be very careful as I slide this in so it doesn't break, but there you go. It's obviously got a density greater than 1 gram per centimeter cubed because it sinks. So now we're talking about density. All right, moving on. Chemical properties. There's only really 2 chemical properties you need to know about because there's only 2. Flammability and reactivity. Chemical property is defined as the ability of a substance to undergo changes in identity with a new and different property. So after they've gone through the change, they have something different. They're no longer the same substance they were before. For example, you see properties of copper down there, forming green copper carbonate. New substances are, when combined with nitric acid and sulfuric acid, forms a deep blue solution when contact with ammonia. These are chemical properties, changing into a new and different form. Here they are: flammability, the ability to burn, and reactivity, combining 2 or more substances to make a new substance. Rusting is a great example, and I think I have a screw here that you can maybe see, I'm not sure, but it's rusted pretty good. It's reacting with the oxygen in the air. It's been in water too, so it's rusting, and we're changing into a new substance. One thing to remember with reactivity is always ask, what was it before and what has it become? It was metal, now it's rusted and it's formed a new substance there. All right. Physical change. We kind of talked about physical properties, so let's talk about physical changes. Physical change is changing the form of a substance without changing its identity. I can take this piece of paper towel, I could rip it in half. It's still a paper towel. I didn't change its identity, just changed its shape. The properties will remain the same no matter what I do to it. Examples: cutting a sheet of paper, breaking glass. All phases of changing states of matter, from a solid to a liquid, liquid to a gas, condensation, evaporation, sublimation, are all examples of physical changes. And you can see some of them down here. I also have a clip right here we're going to take a look at. This is my old barn, and you can see what happens as a physical change as the barn comes down. All right, we're changing shape. We're going to change the length, the width, the volume of the barn, and textures are going to start changing. Here in just a few more seconds, the whole thing is definitely going to physically change. All right. Still a barn, just in a different form now. We just simply changed a few other things about it, but it's still a barn. We haven't changed its actual identity. Chemical changes, though, are a little bit different. It is a process that involves 1 or more substances changing into a brand new substance with totally new properties than what it had before. It's no longer the same thing. New substances have different compositions and properties from its original substance. Always ask yourself, can I undo the change? Can I unbake the cake? No, I can't. Chemical change. Can I unexplode the firework? No, I can't. Chemical change. All right, so those are some clues that a chemical change is taking place. Here's that same barn, but now a chemical change is taking place.
Hello Science Gurus, it's me, Mr. Miller. In this video segment we're discussing chemical changes. The barn that we just previously saw in our physical changes clip is now being chemically changed. And right there's a great example of flammability, the ability to burn. But there are several other indications that a chemical change is taking place right away. You can see the smoke going up in the air as well. So we're changing the wood into a gas, all kinds of new chemicals being produced from that burning. The wood itself is changing colors due to the chemical changes. You can hear snapping and crackling, so we hear sounds being produced. The heat is pretty intense. I'm probably close to 100 feet away, and it's really very, very hot. You can smell it, the odors that are being given off, all indications that a chemical change is taking place, changing the barn into something totally new with totally new properties. All right, that's our chemical changes segment. See you guys later. Science rocks.
All right, so there's an example of chemical change. Can't undo that and turn it back to the barn. Chemical changes, what are some signs that a chemical change take place? We talked about rusting right there. We talked about flammability. Other ones, change in color or odor is another one we mentioned in the video there. Formation of gas being produced, formation of a precipitate, which is a solid, change in light or heat. You see that with fireworks. You definitely see light, you see heat, you hear sounds, whether it fizzes, whether it foams, which you see down here, all examples of chemical changes. You see any of these things happening, most likely it's a chemical change. Let's look at some examples here. Rusting iron, it's a chemical change. Dissolving in water, that's a physical change. Burning a log, you should have said, chemical change. Melting ice, so we're going from a solid to a liquid. It's still water, so it's still just a physical change. Grinding spices. All we're doing is changing the shape of them. Physical change. So what type of change are these? Well, we have regular woods, and then we burn it. Well, if we're burning it, we're changing it into a new substance, so you should have said chemical change. There's a nice, beautiful lake. It's a liquid, but then it gets cold out, and it becomes a solid. Well, if it's just changing from a solid to a liquid or liquid to a gas, it's still water, just in a different state. So that is just physical change. Glass. Now I break it. It's still glass, just a different shape, different form. Even a little bit different texture too, because it can cut you. That's just a physical change. Up in the top corner, we see a bunch of ingredients for baking a cake. Then it turns into a cake. Now, I had to chemically change it. It's a new substance now, and I can't undo that cake. So, I can't unbake it. It must be a chemical change. The last thing we're going to talk about is law of conservation of mass. We learned that a law is something that's been proven time and time again. The word conservation comes from conserve, meaning to save. So in essence, what we're doing is saving mass. Although chemical changes occur, mass is not created nor destroyed, and that's what this law says. No matter what we do, we're not creating it, we're not destroying it, we're just changing its form. The mass of the reactants equals the mass of the product. Now you can see that down there. The mass of the reactants, the things that we're going to react and combine together, so those added together will equal what happens in the end. You can see that, 300.23 grams. It's the same over here, no matter what you do. When we mix them up, you're going to get the same thing. A plus B will always equal C. That's what the law of conservation is saying. You're not going to lose anything. Nothing's gained, nothing's destroyed or lost. And I'll put some arrows in there so you guys can see what I'm talking about. Another way to look at it, the law of conservation of mass in simple terms for maybe 6th graders, the mass of all the parts equals the mass of the whole. So if you take all the parts of the airplane and you find the mass of all these individual parts, then you put it together, the mass of this here will equal the mass of the plane when it's all put together. That's what the law of conservation of mass is stating. All right? So, that's the end of this section of notes. Make sure you glue these in.